In this video, we'll determine the molecular geometry for BrF5. This is bromine pentafluoride. So the first thing we want to do is look at the structure for this bromine pentafluoride, how the atoms are bonded and how many lone pairs we have. So in this structure, we can see we have 1, 2, 3, 4, 5 fluorine atoms, and then we have this lone pair, this non-bonded pair of electrons. So let's take a look at what this might look like in 3 dimensions. This is in 3 dimensions, but a little bit more in 3 dimensions. So we'll imagine that this is our central bromine atom, and we're going to add 5 fluorine atoms. 1, 2, you can see they spread out as far away from each other as they can. 3, still spreading out. 4, that gives us this tetrahedral molecular geometry. And then 5. And if we look at these 5 atoms, we have this trigonal bipyramidal molecular geometry. But don't forget that lone pair. So let's add the lone pair, and things will repel from that as well. And we end up with this molecular geometry here. This is square pyramidal. You can kind of see the square there, and then it's on a pyramid. So the square pyramidal with that lone pair on the top. If we looked at the electron geometry, where we take into account the atoms and the lone pair of electrons, that would be octahedral. Let's go back to our structure. So remember we said we had 1, 2, 3, 4, 5 atoms attached to our central bromine and a pair of non-bonding electrons. Let's take a look at this table here to help figure out the molecular geometry. So we said we had 5 atoms and 1 pair of electrons. So we have 6 things attached to the central atom. And we have 1 lone pair. That means our geometry, like we said before, is square pyramidal. If you're using the Axn notation to figure out the geometry for BrF5, you would have your central atom, that's A, and then each one of these fluorine atoms, they would be X, and then that non-bonding pair, that's N. So you'd have A, X, 1, 2, 3, 4, 5, and then N. And that works out to be, again, square pyramidal for the molecular geometry. For the electron geometry, we do have an octahedral electron geometry. Let's go back to our model again. For an ideal square pyramidal molecule, we would expect these bond angles here to be 90 degrees. These fluorine atoms are very electronegative, so they're going to push against this lone pair here. They're going to be pushed down some, and this will be less than 90, probably around 85, something like that. This is Dr. B with the molecular geometry and bond angles for BrF5. Thanks for watching.